questions from previous tests. However, they are not regurgitated. In other words, if, let's say, one question said the color of the sky is, and gave you black, green, purple, whatever, blue, and so the right answer was blue, now the blue might be in the question saying the blue, whatever is the sky, the ground, whatever. Make sense? Okay, so they're not some of them are cut and paste, but some of them I've switched it and put the answer in the question, in the question, in the answer.
It's unfair.
A little difficult. Just make it
Tricky.
I know. Just in all honesty, if you study the test, again, that's 70%. We'll do that. The last 30 points are case studies. So in other words, I give you a scenario or a case study, and then there are 4 or 5 questions you have to answer about that case study. So think of some big things that we've talked about that have covered numerous lectures that we've had. Diabetes, correct, because that can be acid-base, that can be diabetes, right? That can be kidney function. What's another one? Right, that's what you just said. What's another disease state that kind of covers multiple lectures? That's still the diabetes stuff.
Renal failure.
Renal, kidney, right? Okay.
Hepatitis.
Cardiac, correct? Cardiac covered it several ones. Okay. I know there's one endocrinology one, and it has to do with thyroid, and there's one drug one. So again, your liver enzymes, the drug, and all that good stuff that would affect the drug. So those are basically, like I said, case studies. So you're going to read a little paragraph about the patient, and then you're going to answer 4 or 5 questions based on the case study. But again, that's kind of wrapping a certain disease into several lectures. Students always tell me that's the easiest part, and in all honesty, they are. But anyway, so that's how your test is going to go. So basically what I did is, as I was reading through your test and I'd run across a question, I jot something down. So each and every one of these has a test question attached to it. Some of them obviously might have multiple test questions because there's only, what, 30-something here, and you have 100 questions. So the parts of a spectrophotometer, remember when we did this way back when, I told you with the spec you had to know everything versus just the principle behind it. So with the spec, what's the first thing? You look at your spec, what's the part that's over here shining through your specimen?
The absorbent.
The light bulb, yes, and then you have a cuvette that holds your specimen. Monochromator does what? Makes your light like in a prism, right? Spreads your light out, okay? And then you have your readout device, and then you have the recorder, right? So the parts of the spec.
The recorder?
That's you.
Oh, sorry.
Okay. And then Beer's Law, that one is actually just the same question, or you're just gonna have to pick Beer's Law out of a lineup. Okay. Theory, uses, and reasons for electrophoresis. So what is the theory behind electrophoresis? What's the principle? What is electrophoresis doing?
Separating by charge.
Separating particles by charge, yes, yes. So what would you use electrophoresis for? What did we talk about that you did separate?
Electrolytes.
No, not electrolytes, that's ISE. Proteins, lipids, right? Remember your lipids, you could separate out your chylomicrons, your VLDLs, your LDLs, and those, okay? So yeah, movement of particles in gel, you've used them for protein, lipids, and isoenzymes. Remember your CKMB, your CK, your, okay. Okay, so what's the theory of nephlometry? Who did nephlometry?
Scattering.
Scattering, yes. Remember the word scattering, yes. And what do you measure with an ISE?
Yeah.
Electrolytes, yes, yes, yes. Okay, so number 3, diagram the movement of proteins in an SPE. So remember your albumin, alpha 1, alpha 2, beta, and gamma.
You're not going to want prealbumin?
I'm sorry?
You're not going to ask for prealbumin?
Maybe. I mean, it might be, but okay. So you can visualize the chart or the graph?
The charts.
Okay, the graph, the protein and electrophoresis. Remember the protein, the albumin.
The one that was changing, the one from the one exam where we could read it?
Yes.
Okay.
Yes.
So that's not, okay.
Okay, but again, what's normal, right? I mean, you
Gotcha.
know, albumin's
Mhm.
first, alpha 1, alpha 2, beta, gamma,
Gotcha.
right? Okay, where is the point of application? Where do you apply the sample?
To the right.
Far.
The negative node.
Okay, so what traveled the fastest?
Albumin and prealbumin.
Albumin. So what traveled the slowest?
Gamma.
Yes. How would you know you used plasma instead of serum?
When the spike in,
You have a high fibrinogen spike. Yes, yes.
Plasma instead of serum, right?
Plasma instead of serum. Because remember, it's a serum protein electrophoresis. So how would you know if they use plasma? Because you would get a fibrinogen spike. Yes.
are you gonna have like the separate graphs like you did last time? Or
No, no,
okay.
the pictures aren't on there.
Okay.
Okay, protein, carbohydrate and protein structure. What's the difference? What does protein have that carbohydrates don't?
Amino acids.
Amino acids.
Proteins have amino acids. Carbohydrates are made up of carbon molecules and
John, CHON.
What do proteins have that makes it measurable in the reference method for protein? Starts with an N.
Oh, nitrogen?
Nitrogen, yes, yes. So proteins are amino acid chains that are organic and contain nitrogen, yes. Okay, protein, so number 5, protein, albumin, and the method of analysis. So how do you get your globulin? If I give you the total protein and I give you the albumin, you would subtract the albumin from the total protein, it would give you the globulin, correct? That little formula is right there for you, okay? So to measure proteins, was the Keldal method, right, was the reference method for protein. KHJALD, Keldal, whatever. For albumin was dye binding, and what were the 2 dyes?
Red and blue?
I'm sorry?
Is it the
If
red
I
and
said
blue?
Barney, would you remember?
Oh, red or purple and green.
Purple and
Something,
green,
yeah.
yes. Albumin is Barney, purple and green. And we already said you could use electrophoresis to identify your proteins, correct? Okay, but that's just another method. Okay, functions of proteins. What is the function of haptoglobin?
Doesn't
to
it-
carry free globin.
Binds free hemoglobin. Yes, binds free hemoglobin. What's the function of albumin? It has several, but what's the main one? So you're going to go through all these test questions, all these previous tests, and you're going to go, oh, that's the question she's talking about. Osmotic pressure,
Oh, yeah.
right? There's lots of functions of albumin. Carries bilirubin, does a lot of things, but the main one, again, is for your osmotic pressure. What does ceruloplasmin do?
Instead of binding copper.
Copper. And what does transferrin do?
Transferrin.
Iron, yes. So list your non-protein nitrogens, the quantity of each, and method for analysis. What is an increased BUN called? Okay, so let's start at the beginning. So what are your non-protein nitrogens?
What are they?
Really no idea.
Urea,
Oh,
creatinine, uric acid, ammonia. Did you take my class? Are you guys here? A lot to do. Yep. Again, BUN is the one you have the most of, right? About 50%. So as far as quantity of each, you need to BUN is the most. And method for analysis. So what is a urease measure? Urease. Urea, yes.
Using type.
What does the Jaffe reaction measure?
The what?
Jaffe reaction. Creatinine, yeah, be bold, say it out loud. Creatinine, yes. And what is the reagent in the Jaffe reaction that explodes?
Is it pyloric? Some P.
Not pyloric.
Some.
You're right.
With a P though.
Yep.
P.
Picric acid, right?
Oh.
Yes, alkaline picrate. Yes.
acid.
And what is azotemia?
Too much or no?
Too much?
Yeah, too much.
Too much what? Too much what in your blood? Emia is blood. Too much what? We're talking about non-protein nitrogen.
Urea.
Too much ammonia.
Yes, too much urea.
Oh.
Yes, BUN is elevated. Yes, azotemia. Okay, number 8 is right there for you. If you have an increase in uric acid, what disease state do you have? Gout. So that's what that answers it for you. All right, methods of determining glucose. You have hexokinase, which is the reference method. Okay. For specimen collection for glucose, what is the specimen of choice for a glucose?
Fasting.
Fasting, and how long would you fast?
8 to 10 hours.
8 to 10 hours, yes, so an 8 to 10 hour fast. What disease are we worried about if we're running a glucose?
Diabetes.
Diabetes mellitus, yes. And MODY is classified, I'll just give you the answer. MODY is classified as a gene protein defect. Remember that one? Okay, 10, again, just the question. Define glycolysis, glycogenesis. Remember those questions on your test? Yippee skippy. Well, you get to see them again. Okay, so enzymes. What is the definition of an enzyme?
The thing which
Protein
breaks down
catalyst.
proteins.
Catalyst, yes. Biocatalyst, yes. What makes a good enzyme for a tissue marker? I just gave you the answer. What's the best? The best enzyme for how do I say this? I'll give you the answer. So enzymes are the most diagnostic, there you go, that's a word, if they are in a single tissue, right, or a single organ. In other words, if it's something that's going to be all over your body, it's not a good marker for, say, heart disease, correct? You know what I'm talking about?
Yeah.
So what other thing did we talk about that has that same rule?
Cardiac markers.
TM
Or
marker.
no.
Tumor markers, yes, yes. Okay. Present in a singular few organs. Enzymes. What are your transferases? What do transferases do?
Transfer.
Yes.
Enzyme.
AST is what tissue?
Liver.
Liver and heart. ALT is what tissue?
Liver.
Liver. What's the difference between acid and alkaline phosphatase? As far as measurement goes.
Basic or acid.
pH, yes, the pH. Acid is obviously
Acidic. Less than 7.
less than 7. Alkaline is obviously,
Greater than 7.
yes. pH is different. Okay, what disease state would amylase be increased in? Pancreatitis, yes. Okay, MI enzymes is the ones for your heart versus protein markers. So you need to know the rise and the fall and the specificity. So you have CK, AST, and LDH is the order that they go in, right? Remember Cal? Right? ST and LDH, as far as those enzymes rising in a myocardial infarction. Which cardiac marker rises first?
CK.
All of the markers. Which one rises first? No. Which one's a good negative indicator? Myoglobin. Remember, myoglobin is the one that rises first and goes away first? As far as your troponins, which one's better? Troponin I or troponin T?
I.
And why is troponin T not as good?
Not as specific.
Specific to the heart, could be muscle damage or.
And it can have interference due to what organ? Renal failure. Remember? Renal failure. So troponin I is more for the heart, where troponin T can be screwed up if you got liver failure, or kidney failure. Okay, you're simply going to define what an international unit is. Remember that question? The enzyme needed to catalyze 1 micromole. I think that's just a copy and paste question, in all honesty. And again, enzyme is just the definition, which you've told me already. It's a biocatalyst. Just same thing. Okay, your electrolytes. What are the 4 electrolytes that we measure?
Chlorine, potassium, and sodium, and calcium.
Sodium, potassium, chloride, and CO2.
CO2 is really an electrolyte.
Yes, remember that's what you use for your anion.
Oh, yeah, that
I
I
just
know.
think it's a gas.
Okay, which one is an extracellular positive charged? Extracellular positive.
Sodium.
Sodium. Intracellular positive charge.
Potassium.
Potassium. Which one would be the most affected if you left the cap off the specimen?
CO2.
CO2, yes. Okay, remember those hemolysis ones? Increase, decrease, whatever. Now think of the whole class, guys. Okay, effective hemolysis on specimens, your electrolytes, your enzymes, your non-protein nitrogens, glucose. So here's what I know. Is sodium affected?
No.
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 Is potassium affected?
Yes.
Yes. LDH affected? Yes. AST? Yes. CPK? No. BUN?
No.
No. Creatinine? No. Glucose? No.
LDH, what was LDH?
LDH is yes, that's greatly affected. AST is affected.
Potassium
Is it LDH?
Glucose is low.
Alright,
Everything's no.
so
except for AST and
lipids,
LDH.
specimen collection. What do we have to do to collect a specimen for lipids? Fasting for how long?
10 to 12.
10 to 12 hours, yes. You remember the Friedwald formula?
What's the
Your
free will?
LDL equals your cholesterol minus your HDL minus your triglyceride divided by 5. I don't believe there's a math question that you're actually gonna have to answer. When can you not use the Fried-Wall equation?
It's over 300.
When your triglycerides are greater than 400.
What was that again, the formula, LDL?
LDL equals your cholesterol minus your HDL minus your triglyceride divided by 5.
When you said greater.
It's greater than 400. Your triglyceride is greater than 400. You cannot calculate the Fried-Wall equation. And that was brought up here very recently. And have you noticed the note next to the schedule? I don't know if you're on the schedule. Are you on the schedule or are you on a different schedule? You know that schedule right there on the wall?
No.
Right outside
I don't
chemistry?
think I'm on this schedule.
Oh, okay. Well, if you pay attention, there's a memo that says right there, if your triglyceride is greater than 400, you must calculate the LDL. Because
Okay.
apparently people were not doing that. So.
Okay.
Or, I'm sorry, you won't calculate, you have to do a direct, I'm sorry. People were still calculating. Okay, so, what causes the cream layer on top of your specimen? It's the big fluffy fats. It's the,
Lipemia?
it's the dust bunnies of fats. Starts with a C.
Oh, man.
Chylomicrons. Chylomicrons, big fluffy fats.
I am guessing. I have no idea how to spell it.
Oh, yeah, that's.
Chylomicrons. Microns. Chylomicrons.
That's close.
All right, what disease is associated with a decreased calcium and magnesium? Starts with a T. Disease associated with a decreased calcium and magnesium.
Not tetany.
Tetany, yes.
Okay.
Lockjaw tetany, tightening of the muscles, yes. I had Charlie horses in both legs at the same time last night. How do you do that? You can't rub them. All
That's why
right,
you have a
hormones
husband.
regulation, thyroid test, TSH, iodine, immune, autoimmune, hypo, whatever. So, where do your thyroid hormones come from, or what controls your what is the starting point of your hormones? Starts with an H. And you're pointing to your head.
Hypothalamus.
Hypothalamus, yes. Your TSH stands for,
Stimulating
and where does
hormone.
it come from?
Your
It
parathyroid?
stimulates your thyroid.
Oh, the pituitary?
No.
Right, your anterior pituitary, right? Yes. And what disease is an autoimmune hypothyroid? Starts with an H. Hashimoto's, yes. Hashimoto's hypothyroid. That's
Hashimoto's?
really that's really the bulk of your endocrinology questions.
I'm glad.
Oh, yeah.
What is Hashimoto?
It was on the test 7. I don't know. I didn't have that question. So.
So what results do you put on a Levy-Jennings chart?
Percent
T.
T. And
What do you put on a Levy-Jennings chart? Your lunch schedule?
what?
What do you put on a Levy-Jennings chart?
That's the one with
Is
the
it-
curve and you draw the box, right?
Levy-Jennings chart, that's where your points are going above and beyond, above and below, so what are those points?
Oh.
Trend.
Right, but what are the points? What are you plotting?
Results.
Of what?
QC?
QC, yes, yes, your QC. Not the lunch schedule or anything else, it's your quality control. Are your pre-posters?
Oh.
Okay, method for determining total bilirubin and the specimen considerations. So what 2 methods did we talk about for determining your total bili? Both of them have 2 names.
BUN?
Oh.
Dinosaurs,
Jurassic Park.
right, Jurassic Golf, right?
What?
And what's the other one? It's a lady's name and her buddy.
It's all with an M.
Yes.
Me.
May Hegman? No, it's
Mina?
disease.
No.
No. Oh,
You go shopping at the
Melanie, Mall.
mall, so Evelyn and
Oh.
Malloy, yes.
Mall.
Evelyn and
Mall.
Malloy.
Okay.
The methods to determine total bilirubin. Okay. So specimen considerations. What will affect your total bili?
The left.
So you have to do what to it?
Protected from light.
Correct. So you either put it in a dark container or
Foil.
aluminum foil. Yes. How does hemolysis affect your total bili?
It doesn't, does it?
Increases it. Yes. How would lipemia affect your total bili? Remember spec. Lipemia and spec.
It would
Increase.
increase it.
Increase your value. Yes. Yes.
What was the first thing? Gendrasic and
Gendrasic Groff, Groff, Evelyn Malloy, those are the
Okay.
two methods that we use to measure it. And it's affected by lipemia, hemolysis, and light. Yes. Okay, the osmometry. So how do we measure the osmolality of a specimen?
Freezing point?
Freezing point depression. That's an easy one, right? Freezing point. We make pea sickles. Yes, we do.
Are we gonna have our blood gas sheet for the final like we did with the last test?
No, not on the final. But I am gonna give you back your tests, but she hasn't taken it yet, so we're gonna kick her out of here as soon as we're done, and I'm gonna give you back all your papers. Okay, so blood gas analysis. First thing, what specimen do they use? Arterial specimen, yes. So blood gas analysis is an arterial specimen. So what is going on in blood gas? Why do we care? What is, now give me the answer what I can say.
It's going to tell us the difference between metabolic and
No,
respiratory.
so I'm going easier than that.
Okay.
How do you tell if it's acid or alkali? Yes, that's the word, yes. So acid-base balance, again, we're checking for your pH, right? What's normal?
7.5.
7.4.
Right, 7.4 is absolute normal, yes. So what's the main system that controls your acid-base balance?
Your lungs.
The who?
Respiratory.
What's it called? What's the first one called? You've had four.
Bicarbonate and carbonate.
Yes, bicarbonate, carbonic acid, yes. In respiratory, they use the Henderson-Hasselbalch equation, which basically says any change in your CO2 or change in your bicarbonate, what is going to change?
Your pH.
Your pH, yes. If a doctor orders us, this is 24, if a doctor orders a sweat test, what disease is he looking for? Cystic fibrosis. Also called 65 roses. Have you heard it called 65 roses? Cystic fibrosis. 65 roses. That's the good way to put it, I guess.
We got our teacher, our biology teacher, for cystic fibrosis like every year on her kid's birthday because it is in high school. That's the only reason I know.
Yeah. Okay, so you guys know that your parathyroid hormone regulates your calcium, magnesium, and phosphorus, correct? All right, well, that's an easy one. You're going to know the normal values for cholesterol, HDL, triglyceride, LDL. Yep. What is a lipoprotein A significant of? It's LIPA, it's on here.
Kidney.
Lipoprotein A. It is a small fraction of your LDL, right? And what is it significant for? No.
CHF?
Getting lining of your aorta, lining of your vessels, what do you get?
Plaque.
Plaque buildup, yes, 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 yes. You're gonna know the normal values of a BMP, basic metabolic panel. Know your normal values for your non-protein nitrogens, that's your creatinine and BUN,
Which one you on?
26.
She's on 26.
I'm not gonna give them all to you, but these are the ones you're gonna need to know, because basically the back page is real matching, is a lot of just matching of normal values to what they are.
You said it.
She just said it.
So know your normal values of your cholesterol, HDL, triglyceride, LDL. Understand what lipoprotein A is what's the significance of a lipoprotein A. Normal values for BNMP, your non-protein nitrogens, which is your BUN and creatinine, and then your myocardial enzymes.
What's on the basic med?
I'm sorry?
What's on the BMP?
BMP, that's your Chem 8. So that's your sodium, your electrolytes, your BUN, creatinine,
Okay.
calcium. Okay, your tumor markers. So, basically it's what's the one for breast? 19.9, isn't it? Don't write this down, I'm just guessing off the top of my head. PSA is for prostate. CEA, thyroid, again, I don't know off the top of my head. Ovarian cancer. So look at those, you know that those are on the final, so make sure you just look at those questions and can answer those. Okay, you have instrument temperature problems. What's the first thing you're gonna do?
Open the doors and put a fan.
Cool it off. What reagent is gonna be affected first by temperature?
Controls?
You said what, reagent?
So they are they end in ASE, so they are
Enzyme.
enzymes, right. Okay, so if your temperature is high, you're gonna put a fan in front of it. What do you have to do second?
Choose reagents? No.
Run controls.
Run controls, correct, correct. And if your controls are still good, just keep putting specimens on and keep running, correct? If your controls are not good, what do you have to do?
Go back to the thing.
Go back to the last good QC result, yes. Well, we usually go back 3 specimens, and if they're all still about the same, we do, but technically we're supposed to go back.
Go back to the
So
next
just
last
follow your
QC.
Okay, so TDM's your peaks and your troughs. What is a trough?
54, you give the dose?
The lowest amount in that therapeutic range, and when do you want to draw a trough?
Before the next dose.
Right before the next dose. So your peak is, when do
Highest.
you draw a peak?
Whenever it's supposed to be.
It varies, yes, depends on the medication. And so again, that would be something again in your SOP, correct? Which level should be higher and which level should be lower?
Peak should be higher.
And if they're not, what are you going to do?
Reject.
Reject them and redraw. Investigate and redraw. Yes, yes, yes. Okay, the drugs you need to know about. Acetaminophen. Why do you take acetaminophen?
Pain.
Why do you take acetaminophen?
It's Tylenol.
Pain relief, exactly. Why would somebody take digoxin? No, digoxin is heart. Why would somebody take theophylline?
It's
Bronchodilator. Why would someone take lithium?
It's
Depression.
Depression.
Okay, the toxic drugs. Your metals such as lead and arsenic and mercury. Ethanol is what? Alcohol, and it's the most common substance we see in the emergency room. right? Why would your opiate come up positive if you weren't doing drugs? Poppy seeds, yes. A high lead level affects what population?
Kids.
Children. And pesticides cause what enzyme to be decreased?
Cholinesterase.
Cholinesterase. You got it. Okay, incident reports and corrected reports. So this is a no-brainer here. If you report an incorrect result, what do you have to do?
Fess up.
Fess up. When are you gonna fess up?
As soon as you find out.
As possible. So you're not gonna go on vacation to Hawaii and come back 3 months later and say, oh, by the way, he really didn't have a heart attack, I spit in the tube, right? Yeah. All right, so yes, incident reports, you send a corrected result and you do it immediately, yes. Diagnostic value of enzymes, tumor markers, and cardiac markers. Here I'm looking for, you want them to be in one organ or one tissue, so it's not systemic, it's not all over your body. When you're having a heart attack, we want a cardiac enzyme to be high. If you're having toe pain, we want the toe marker to be high, right? Does that make sense? So single tissue, one tissue, or single organ. Yes. Okay, fetal lung maturity. What methods would you use to determine whether a baby was mature enough to be born?
The alpha fetal.
Lamellar bodies, LSPG, FLM, and then what was the non-protein nitrogen that we would measure in the amniotic fluid? I'm sorry? I just didn't hear you. It's not.
I know.
Not that it was the wrong answer. It starts with a C. Non-protein nitrogen. Which ones are they?
Creatinine.
Your UN and your
Creatinine.
creatinine. Yes, creatinine. Okay, remember way back when you learned all about different types of pipettes?
You mean we couldn't forget that?
No. So what would you use a micro pipette for?
Small amounts.
Small volumes. And what is important to do with a micro pipette? No, not blow out. What did you have to do? Rinse it. Yes, you got it. In chemistry, what type of pipette did I constantly make you go get when we were doing manual procedures and we were measuring anything in chemistry?
Serological.
Volumetric, yes. Volumetric. And there are 3 classifications of water, and they are
Tap, DI, and
Reagent.
ultra pure. So 1, 2, and 3, right? So what reagent or what water did I keep making you go get? The water that we needed for that. The water we yes, you take 2. Yes.
Was 3 the tap or was 3 the ultra pure?
3 is tap 1.
Tap.
1 is the that's the CSI. You know where you don't want it to. Okay, so what test do we run for liver function?
ALT, AST.
AST, ALT, GGT, Jurassic Park, and Evelyn Malloy. Which ones were those? What were they measuring?
Total bilirubin.
Bilirubin, yes. So your liver enzymes, your bilirubin. Anything else? And safety data sheets. What information is on a safety data sheet?
Hazards.
Of
The
Fire.
chemical.
something on the floor or
Everything.
The chemical you're using.
chemicals or reagents, yes. So what kind of information can you get off of a safety data sheet?
PPE, clean,
What PPE to do, how to clean up a spill,
How
tells
to
you the
dispose.
manufacturer, where it came from,
how to
first
dispose,
aid, if you drink it, what do we need to do for you?
disposal.
So, not that you're gonna need to know, but section 6 is spill, so S and S, and then first aid is 4, so F and F, and, yeah, and 9 is your, if you can't remember anything else when you go to your registry, do know that section 6 is for spills and section 4 is for first aid. F and F and S and S, what to do. Yep. Yep. Use an eye wash or a shower and move to fresh air.
So this will be 4 people each.
Yes. So one person's gonna do the manual control, one person's gonna do the calibrator. One person's gonna start it up, and one person's gonna shut it down. And you have 1 hour to do, find the absorbance and transmittance on a standard, to do a manual procedure, and to run a specimen over there. And you should have plenty of time.
And the same for down here, we could start the final this way.
Right, but you cannot start your practical early.
Right.
That has to be on time, because when everybody's done, I'm gonna reset the lab for the next group. Yeah. Yep. Any questions on anything else?
Everything needs to be turned into today, correct?
Friday.
Friday.
Friday, I need your, disease state, and you turned your thing in, and you know what you have due to me. Everybody else has got everything except the disease state, and then you have your, what is it, MTS or
Yeah,
whatever.
So let's just put that in our.
And just put that in your portfolio, right? I don't.
So we
need
don't need to
anything
do it,
on
okay.
that. No, you don't turn that into me. I guess Jean just takes points off of your portfolio if it's not in there. That's all I know for that.
It's the protein one
Any other
for freezes.
questions? And chemistry is all done, and then I have to have everything to Jean by Monday, so that means I will have your final grade and everything by Monday.
Cool.
Yeah, short deadline, huh?
Yeah.